We are going to discuss problem 606, construct string from binary tree from Leetcode. So it is, first of all, it is marked as easy category, but in my opinion, either the problem statement, the way they have presented the problem statement is not good, or I guess they should put this question in medium. So with that being said, let's start with the question. So the question is given to us like, given the root of binary tree, construct a string consisting of parentheses and integers from binary tree with pre-ordered traversal way and return it. Omit all empty parenthesis pairs that do not affect the one-to-one mapping relationship between the string and the original binary tree. Okay, got it. So question, what they are trying to say is they are given us with one root of the binary tree, and we have to do pre-order traversal. But there is one twist in this thing, that whenever we are doing pre-order traversal, we have to do it along with some parenthesis, and we have to remove the parenthesis which will not be affecting our one-to-one mapping. I will be explaining you in detail what they mean by one-to-one mapping. So let's start with the explanation part. So the tree that they have given to us in the first example is something like this: 1, 2, 3, and 4. So now, first of all, what happened pre-order traversal? So let us understand that, and after that we will look after that one-to-one mapping and that parenthesis thing. So first of all, let us see what is pre-order traversal. So in pre-order traversal, you have to traverse recursively in this method. That first of all, you have to traverse the root, then you have to traverse all the left, and once you are done with traversal of all the left node, then you have to traverse all the right nodes. So this is the pre-order traversal. So let's say if someone says to me that write the pre-order traversal for this binary tree, so how I will do it? So first of all, as I told you, we have to start with the root. So here the root is 1, so I will write 1 over here first of all, and after that, first of all, I have to cover all the left nodes, and once I am done with covering all the left nodes, then I will start with the right nodes. Okay, so 1 was the root, so I have written 1 as it is. Then I have to move in the left direction. First of all, I have to complete all the left nodes. So on left I can see there is 2. So again you can see this portion as one different binary tree, for which this 2 is as root. So again you have to write first of all root. If you see just this binary tree, you will see this as one of the independent binary tree, not a part of this tree. So you will say this 2 as a root and not a children. So first of all you will write 2. After that, again you will complete all the left nodes which are possible. So again there is one left node to this, that is 4, so write 4. Now you can see that you are done with all the left nodes, so now you will complete all the right ones. So for right over here, starting from here, there is no node, that is empty, that is null, so you will write null over here. After that, recursively you will come up and will traverse to the right node. So the right node to this which is remaining is 3. So this 1, 2, 4, null and 3 is the pre-order traversal for this binary tree. So I hope now you guys are clear with what is pre-order traversal. And now let us try to understand what they mean by one-to-one mapping and removal of those parentheses. So what they are trying to say is, let us again consider that same tree. There's 1, 2, 3, and then 4. So in this tree, whenever we will start, what they are telling us, that something like this. Let's say 1. Then for 2, you have to put parenthesis, as 2 is one of the children of parent 1. After that, again traverse, following the pre-order traverse to the left. So 4. Now you are complete with all the left nodes, so you will recursively come up and traverse all the remaining right nodes. So here for 2, there is no right node, so I will just put empty parenthesis, and after that, coming upward recursively, I can see that for parent 1 there is one right child, so I have to write that right child also over here. So it will look something like this. But let's say if I remove this parenthesis and if I write this in this manner, still it will remain same. Means this thing and this thing, there is no difference in this, even if we remove this empty parenthesis. But let's say we have something like this 1 2, and instead 4 being the left child, for this example I am keeping 4 as one of the right child of parent 2 for just for the time sake. And let's say this is the tree. So now in this case, let us try to again write pre-order traversal along with parentheses. So let's again try to do this. So let's say 1, then again traverse to the left, so 2. Now you are done with all the left. Now you have to recursively travel up through right nodes to cover the remaining right nodes. So 1, you have already covered all the left nodes. So now for this there is no left node, so I have to put empty parenthesis. And now we are done with all the left nodes, so we will be recursively covering all the remaining right nodes. So for here we have one right node, that is 4, so I will be writing 4 over here. And once I will write 4, then I will say that the remaining one right child is 3. So it will look something like this. Now let's say if you try to remove this empty bracket, that is empty parenthesis from over here, then you will get some resultant of this kind 1 2 4 and 3. Now by looking at this order, you may not node is either left node or either right node. You can't confidently say by looking at this resultant expression. So that's why you can't eliminate this empty parenthesis, that is this brackets from over here, because if you remove this, you will from expression you might not extract that whether the that node is left node or a right node. So in order to maintain the particular mapping of the tree, we have to keep this empty parenthesis, and that is why they are saying that you can omit all the empty parenthesis pairs that do not affect the one-to-one mapping. But if in this case you can see that if we remove this pair of brackets or parentheses, then we may face some errors in our final expression, so we can't remove this. So this is what they mean by one-to-one mapping. But if it is not affecting like in the previous case, we can simply omit it. So I hope the question as well as example is clear to you. So how we can form some logic to code this out. So what we can see over here is, first of all, let's say if I write this expression, that is my output expression, and we try to observe it, what are we observing over here? First of all, what we are observing is whenever we are encountering any left nodes, we will simply put an open braces before it, and whenever we will end with covering all the left nodes, and whenever we encounter any right node, or let's say empty right node, so in that case we will start braces for that respective parent. So here the parent is 2 and 4 is child of it. So first of all, as far as we are able to find the left nodes, we will keep adding it, and before adding those nodes left nodes value, we are adding the open parenthesis. But as soon as we are done with covering of all the left nodes, and as soon as we either encounter null right node, or let's say some right node with some value, let's say right node with some value, so in both of that case to add the closing braces for the respective parent. And once we are done with that, after that we will start adding the right nodes. So this is what we are trying to do. So we can do one thing. Let's say, let's first of all we will make one string, and we will call the string as str, and initially we will keep the string as empty. Now we will apply some logic over here, and after applying some logic we will get our final answer, and we will be returning that final answer. That is, I will return that str only. we will do operation in this string variable only. So what logic we can use over here is, once we have defined and initialized an empty string str, as per the question we have to apply the preorder traversal. So we will start preorder traversal. Here I will be explaining you the recursive approach. This can also be solved using iterative approach that we will look in some other video, but right now I will be going with the recursive approach first. So first of all, I will call a recursive function preorder traversal, and it will be called until we don't find any null root. So I will start preorder traversal with my given root and with my given empty string. So I will start my preorder traversal, and the function for this preorder traversal will not return us anything. So I will mention the return type as void for this preorder function, and it will take two parameters. One is our root and one will be our empty string. And what we will be doing inside is, we will check that if we find our root equal to null, so in that case simply return. You don't have to do anything, just simply return from there. But if that is not the case, then you can see over here in every example, before adding the value, here you can see before adding the left value, since in preorder traversal we will be completing all the left nodes first and then we will be going after right nodes. So before adding any of the nodes, let's say right node or left node, we are adding one closing bracket. So simply we will write str plus is equal to this opening bracket. After that we'll be adding value and yes, of that root to our str. Once we have opened the bracket, then we'll be adding the value, and as per the pre-order traversal we will keep on recursively traverse through all the left node as far as possible, and once we will exhaust all our possibility for left, then we will go for right. So I will recursively call for root left until it is possible along with my string, and I will do it until left node possibilities are exhausted, and after that I will recursively go after right nodes in the similar fashion. And once I'm done with it, at every point of time I have to close bracket recursively, as I have put two closing brackets, or you can say parentheses, in order to complete this thing, and that I have done recursively till that parent, that is the 2, is the parent of 4, I can say in that manner. So I will be doing till that. So recursively will be closing this bracket also. So now you will think that this will work, but no, here is again one catch. There is one thing that we are missing. When I was explaining you the example, at that time I have told you about one thing, that about one-to-one mapping. I have told you about one-to-one mapping, and in one-to-one mapping we can't omit this empty parenthesis whenever our left is equal to null but our right is not equal to null. So whenever our left node is equal to null and right is not equal to null, in that case I have explained using one example just just a while ago, that we can't omit this empty brackets, but other than this we can omit. So but in this code you can see we have not covered this case, so this will give us error. So we have to cover this case also. So before this pre-order traversal I will just insert one line, that if my left node is equal to null, and along with that, that is and person, but my right node is not equal to null, in that case I have to add one empty bracket also to my string in order to follow one-to-one mapping. So I hope this explanation of logic is also clear. Now let us move on to the coding part. So here is the code to our problem. So as I told you, we have started with taking an empty string. I have used variable str and we have initialized it with empty string, and after that we have called function preorder recursively until we find our root as null along with my string. and after that we are returning this string. And why I have written this sub str and all of those things I will be explaining you in a while. So first of all, let us try to understand this preorder function. So in preorder function, as I have already explained during example, that we will be moving in root, left and right strategy. So first of all, we will check if our root is equal to null. If it means there is no value, then there is no point of going ahead, so we will simply return. But if we can go ahead, if the root is not equal to null, then in that case we have to put one open bracket, and after that we have to add that particular value. But here the values are given in integer and we have to return the string. So first of all we have to convert this value into string. So I have written two string of root value to convert that integer into string, and after that we will be recursively calling root left until our all the possibilities of left nodes are exhausted. And once I'm done with exploring all the left possibilities, then I will explore all the right possibilities, and then finally recursively as I will be going upwards, I will be just adding my closing brackets. And along with this, that one condition for one-to-one mapping that I have told you that we have to check is that if root left, that is if the left root is null but our right root is not equal to none, in that case you have to add empty brackets, empty parenthesis, and you cannot omit this, because if you omit this condition, if you omit this empty parenthesis over here, then you may face one-to-one mapping error. So that's why this is the most important thing that we have to consider. So that's it, that was the pre-order function. And after that I have returning something like once str.length minus 2. So what is this? So you can see over here that starting from the first root, uh, now starting from the first node, that is this node 1. So in this code if you look carefully, that it will add parenthesis over here before 1 also, and at the ending it will add parenthesis and parenthesis of 3 also. It means that we have to remove the starting and ending parenthesis that is extra for us, so we have to remove it. So basically I am returning the substring starting from index 1 till minus 2. So I will be able to omit the extra added parenthesis at the starting and at the end of this string. So that's why I have written that particular substring. So I hope you are also clear with this code. So now let's try to submit it. Okay, so yes, our code is working completely fine. So that was it.